Oops. Okay, what we're going to learn today is using the critical value approach. All right? So, let me think. How do I want to say this? The critical value approach. We're doing the same thing as far as the test statistic. Now, I want to refresh your memory. The homework you just did was using this equation to find your test statistic because you were given the population standard deviation and you calculated your Z test statistic. You then used it to find the p-value. That was last week. This week, you're doing the same thing, but this time you're given the sample standard deviation. And because you're given the sample standard deviation, you're really calculating a t-test statistic. And you might use it to find the p-value, but you need to also use it to find the critical value. And these are the two formulas for critical value. This top one for Z, the bottom one, let me get this out here. The bottom one for T. Now, I want to jump to an example using the Z. So I'm going to slide 15, 16, 14. Here we go. This is now going to use the critical value approach. You saw this last week. What's the average number of TVs per household? If we could call all the households in America, we're saying it's 3, but we went ahead and called 100 randomly chosen households. And instead of 3, it ended up being 2.84. And so we calculated our Z because we were given the population standard deviation of 0.8 TVs. So we calculated our Z to be -2. Now let me refresh your memory. We called 100 households and we got an average of 2.84 TVs. We're testing that against 3, and it is pretty close, but because our sample size is so large, it's not as close as we thought. There is our test statistic, -2.0. Now, look at the significance. Let me go back. The significance on this, it says 5%, sample size 100. So I'm going to go right here, because this is Z, I'm going right up here, and I'm going equals NORM dot S dot INV, parentheses. This goes in here. We're trying to find out if, here's our null hypothesis, equals 3, our alternative not equal to 3. What goes in the parentheses now that you see that hypothesis? 5% significance. Think about it. What's the confidence?
So 0.025.
No, hang on, what was the confidence? 95% confidence because it's 5% significance. It says, two-tail, use confidence plus half significance. So what goes in the parentheses? 97.5%, 0.0975. 0.975, I said it wrong, but that's what I meant. Equals, here we go. Equals NORM dot S dot DIST. Did I do it right? No, INV. All right. Here we go. INV, parentheses, 0.975, confidence plus half the significance, and that's all that goes in there. Here is our critical value. I'm rounding to 2 digits just because there's so many 9s there. 1.96. Now, when you found the critical value, just put a plus minus in front, just to tell me and yourself that you just calculated both the right and left-hand side critical values, the negative and the positive. So just get used to it. Every time you find the critical value, when you're using the critical value approach, you really just found both numbers. Look at this bell curve. Hypothetically, let's pretend this is plus 1.96 over here. Here's your 0. So let me go equal distance here. Here's your negative 1.96. There they are. Let me say this again. When you calculate your critical value using the critical value approach, it's just like we did when the confidence intervals find the critical value. But the difference now is you're comparing your test statistic to the critical value. Here's the comparison. What's the test statistic in this problem? Let me bring it up. Right there. -2. Where's here's -2 on here. 0, here's 1, let me put a 1 here, here's probably 1 right here, here's -1 right here. -2, I'm putting it right here. Right there. Everybody see it? Here's how you determine whether to reject or not reject. If your test statistic is outside the critical values, you must reject. I'll say that again. If your test statistic, -2.0, is outside the critical values of positive and negative 1.96, you must reject. If your test statistic is inside your critical values, inside positive or negative 1.96, somewhere in there, like 1.5 or -1.5, you cannot reject. Since ours is -2, can we reject or not reject? We are recording, and you guys all said it so fast that I don't think it recorded. So let's try again. Okay, are we rejecting or not rejecting? Yes, we're rejecting. Our -2 is outside the 1.95 and the -1.96, excuse me, 1.96. So we reject it. That's how you get it. That is it. And all I need to see is that you're making that comparison. Ready? Since our, I'm using all the words. I know some of you won't use half these words. Yes, I know. Okay. Since our critical value, which I put in parentheses here, plus minus 1.96. Oh, wait, I'm sorry. Stop that, erase that. Since our test statistic, which is -2.0, is outside our critical value, parentheses, plus minus 1.96, we must reject the null hypothesis. Don't forget, we don't accept anything. It's either reject or not reject the null hypothesis. That's what we're doing. Since our test statistic, -2.0, is outside our critical value plus minus 1.96, we must reject the null hypothesis. That's it. That's how you use the critical value. It's that easy. I got another example ready. You know what? I just realized we could do, is the homework still open? Yeah, let's do the homework. Let's use, is this one right here? Look, we already have the test statistic. The test statistic's 2.5. All right, so now let's find our, is this a Z or a T? This is a Z. Here's a Z right here. All right, we have our test statistic, which is 2.5. Let's find our critical value. Here we go. Equals norm dot S dot INV, parentheses, I gotta look up here, figure out what the significance is. Oh, it's 1%. Here it says use, is this one tail or two tail? It's one tail. So all we're using is the confidence. We're not using confidence plus half significance, just the confidence. And what is the confidence for this problem at 1% significance? 99.99. So here we go, we're gonna find the critical value. Equals norm dot S dot IMV 99, not 975, 99. Here's our critical value, plus and minus 2.326. Plus and minus 3.2, is that 3 or 2? 2.326. 2.326, is that right? 2.326, there we go. Let me go back to the problem. Let me move this a little out of the way. There's our test statistic, 2.5. There's our critical value, 2.3. Here's my sentence. Help me fill in the number. Since our test statistic, what goes there? 2.5 is outside or inside? What is it? Outside or inside? I can't hear you.
Outside.
Outside our critical value, what goes there? 2 plus or minus 2.326, we must reject the null hypothesis. And look here, we use p-value, we can reject the null hypothesis. No matter which approach you use, you get the same answer. If using p-value says reject, using critical value says reject. Using confidence interval says reject, which we haven't learned. Confidence interval we're going to learn next next week. Do you see it? Now we gotta go from, go ahead, you have a question?
Yeah.
Go.
What is the test statistic for?
Right here on this homework, 2.5, right there. 2.5 is the test statistic, and the critical is 2.326, so on a number line, 2.5 is on the outside, if you think of a number line. Now we gotta transfer what we just learned to if we have the sample standard deviations. What are we doing on time? Okay. Okay, let me take a look, sample standard deviation. So, we're going to I'm on part 2, chapter 9 slides. Where's the example? Here we go. You ready? This is population, it's another population. Let's get the sample one. Here's the formula for the sample, here's the formula. The sample mean minus the hypothesized mean divided by the sample standard deviation over the square root of the sample size. Just like the other equation, the only difference is we're using sample standard deviation instead of populations. And that we're calculating a t-test statistic instead of a z. So let's start by using p-value. Let's refresh our memory on the p-value for t. Here's the p-value formula. Equals t, d, I, s, t, parentheses. This is your test statistic, comma, degrees of freedom. Oh, yeah, that's right, freedom. And then either a 1 or a 2, depending on what tail it is. Boom, there's that one. Drop the negative. Drop negative on the test statistic. Just put whatever, even if you get a negative test statistic, put it in as a positive. It's just much easier that way. And then you know on the critical value that it's going to be both plus or minus anyway. We're using the whole thing. So let's get to an example. Here we go now. This is what we're now going to this week's homework, where we're given a sample standard deviation instead of a population. Just like last week's homework, but with sample standard deviation. The average cost of a hotel room in New York is said to be $168. There is our null hypothesis. Or both hypotheses are 168. Random sample of 25 hotels results in a average or mean of 172.50 and a sample standard deviation of 15.4. Test this at 5% significance. It doesn't say anything about test if the average hotel is more than 168. It doesn't say if it's less than. It just says test if this is true. This is a two-tail. So here you go. The mean is equal to 168. The mean is not equal to 168. Let's start with the test statistic. Here's our formula right here. What goes on the left-hand side of the numerator? What's the number we're going to use for the left-hand side of the numerator? 172, does it say 50?
Yeah.
50. Minus, what's the right-hand side?
168.
168, the hypothesized mean, over. Sample standard deviation is what?
15.4.
15.4 over the square root of the sample size, which is how many?
25.
Where is it?
25.
25? I don't even see it.
Right.
There it is, I see it, thank you. 25, I put parentheses around here because you do the numerator, you do the denominator, then you divide last. Square root of 25 is 5, 15.4 divided by 5 is 3 point blah, blah, blah. Za, 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 zoo, zoo, zoo. Here it is, 5% significance. Here it is. What our test statistic is right here, 1.46. So this comes out to 1.46. I'm going to start with p-value. Even though this is starting with critical value, I'm going to start with p-value. Don't forget, 1.46. So here we go. Equals t, D-I-S-T, parentheses, 1.46, comma, degrees of freedom. You said the sample size is 25, so 24, comma, one tail or two tail?
Two.
Two tail it is. Equals. Here is, this is our p-value. We told it was a two tail. We never have to multiply by 2. This isn't like z. Once you tell it's a one tail or tell it's a two tail, it's giving you the significance. You don't ever have to multiply by 2. Just take it as it is right there. 0.1573. Where am I? Right here? 0.1573. This is using p-value. Are you ready? You're supposed to compare that 0.1573 to the significance. Let me go back to the problem so you can, come on. What was the significance? 5%. This is 1573. Is our p-value more or less than our significance? Can't hear you. P-value more or less than our significance. Is 0.1573 more or less than 0.05? More than. Anytime our p-value is more than our significance, do we reject or not reject? Not reject. We can't reject. There it is. You wrote it out. Our p-value, 0.1573, is greater than our significance, 0.05, therefore we cannot reject. I'm going to add words now, just so you can start hearing the next step that's coming. Therefore, we cannot reject. We do not have evidence that the average hotel in hotel room in New York City is different than $168. There it is. I put in words what not rejecting means. Now, we gotta use critical value. I'm gonna use this formula now. Are you ready? Same information. This is a one tail or a two tail. It's a two tail, so we don't have to double our significance. Just use the significance. Equals T-I-N-V. The significance is 5%, 0.05, comma, degrees of freedom. Sample size is 25, 24. There we go. Let's get Excel out. We're using critical value now. Where should I put this one? Right there? Equals, what is it? T-I-M-V, T-I-M-V, parentheses. The significance is 5%. Whoop, whoop, whoop. There we go. I don't have to double it because it's not a one tail, it's a two tail. Equals and not equals 2, so we don't double it. And then comma, did I do the comma? Then it's degrees of freedom, 25 is our sample size, so 24, parentheses. Here is our critical value, plus and minus 2.0638. 2.0638. Now, look at that, critical value. Let's go back to our test statistic. Test statistic, 1.46. Think of the number line. Plus and minus, let's see, we're way out here. This is a negative 2.0638. This over here, this is plus 2.0638. Our test statistic's 1.46. My question for you is our test statistic inside or outside the critical value? Oh, not again. Inside or outside? 1.46 inside or outside our critical value? Inside. Therefore, we reject or not reject?
Cannot reject.
Cannot reject. Anytime your test statistic is inside the critical values, you cannot reject. Just like when we did p-value, we could not reject. Because this was greater than 0.05. You get the same answer no matter which approach you use. But you got to show me you can use all three approaches by the time we get to the second quiz.
For the Excel formula, the TTIST, for what approach is it? Is it the p-value?
This one's the p-value approach, and then this one's the critical value approach. So this is the p-value getting 0.1573 to compare to 5%. This one got 2.0638, which is the critical value that we compared with the test statistic. Yes?
So if the homework says, like, solve it using the critical value, would we just find the original test statistic?
The test statistic
and
and this critical value,
Okay.
and then you gotta compare them, and then you gotta tell me if you reject or not.
So we just don't use the t-dist?
Yeah, you don't have to
Okay.
use that one, only if it's asking for p-value would you use this.
Okay.
Which, I think question 2 is asking for p-value, or else question 1, I can't remember which. One of the first ones on your homework for this week is asking for p-value, and you're using this. And then the other ones, I think you're using critical value, but you're using this.
If we're testing a one,
Go ahead, go ahead.
testing a one, we're just putting like, how much you and you just put nothing there. Can we put comma 1?
one there, comma 1 if it's one tail, comma 2 if it's two tail. That's if you're doing the p-value. But tell me what you're gonna do in critical value. If this was 5% significance, what would you do here if it's one tail? What do you put there, Lily? If this is a one tail, instead of putting 5%, what would you put there? Help her out.
10%.
No? No? What would it be? 10%. You have to double that significance if it's a one tail. So be careful, it's so weird. Wait, I'm sorry. Go ahead, David.
Can you remind me how different one tail versus two tails?
When you say the difference, what do you mean by the difference? Using what?
Like using the TD6L.
This one?
Yeah.
The difference is, if it's a one tail, you'd put a 1 there. If it's a two tail, you put a 2
No,
there.
yeah, but how do I know it's one or two?
Oh, you know it's 1 and 2 by the hypothesis.
Okay.
If this says equal and not equal to, see that one right up there? Then you know it's two tail. If that had a greater than or less than anywhere there, then you know it's one tail. Okay? I think it was back here and that'll come up.
So for the critical value formulas on the right side, you can only use the top one if it's two.
Now, here's the deal. He's asking if it's one tail, and you're using the critical value approach. I'm saying, still use both critical values. This is a one tail, but I'm using both the minus and the plus, because wherever your test statistic lands, you're measuring against one of these, so you might as well measure it against both. Is it inside or is it outside? So always, whenever you're doing critical value approach, use both the plus and the minus. Get in the habit of just using both when you're thinking of the number line. I don't expect a drawing here, I just want you to be able to visualize what's going on though. I think, go ahead, follow-up question?
Well, so let's say it's not a two tail like this one, you can only use the T inverse.
This one is a two tail though, hang on a minute. Say that again, did we do a one tail? Darn it. Okay, hypothetically, if it's a one tail.
Yeah, which critical value formula for Excel would you use?
This is the one for both one tail and two tail. You just have to decide what that's gonna be based on one tail and two tail. That's, if it's 5% significance, you're using 5% significance if it's a two tail. But if it's a one tail, you've gotta double the significance. You gotta put 10% there instead of 5. When we get that, then we'll go here and then we'll go over here.
Okay, so with the critical value approach, you would be, determining whether it's like inside or outside, but then with p-value, just if it's more than.
Or less than. She's asking about what makes the determination on the two different approaches. If it's critical value approach, it's all about if your test statistic is inside or outside to make the decision. If it's a p-value approach, it's all about your p-value versus your significance, if it's greater than or less than.
Okay, and then another question I had, you said that this up there would be for p-value, but like.
For a p-value, if you happen to be given a sample
Oh,
standard
okay,
deviation.
that's only for t.
Only for T, if you're given the sample standard deviation, which is this week's homework is all about T.
So we would be using that whenever.
For the p-value, and this one for the critical value.
But only if it's asking for p-value.
P-value approach, yeah. So
If
you
it's not-
only use that for p-value approach, and you're only using that for critical value approach, and they're either asking for one or the other on your homework this week.
Okay, so if it's asking for t and it's not p-value approach, which Excel equation would we be using?
If it's not p-value approach, it would be this equation right here that I just used, equals TIMV parentheses, right here is the significance, let me put that in here. Significance, then the degrees of freedom, but if it's one tail, you gotta double that significance.
Okay, and then if it's.
I had that all typed up and somehow it erased.
And if it's two tail, we would be using the one on top.
No, this is only if it's a Z. No, this week's homework will never use this.
Okay.
That was last week's homework. But you need to see how to use critical value on a Z though. That's why I had to put that up there.
Okay, thank you.
All right, go ahead, over here and now come here.
It was the same question.
Same question, go ahead. No?
No.
That's it? For questions? Yes.
So, are we trying to figure out if the critical value is above or below the test statistics? Or
No, you're trying to figure out if your test statistic is inside or outside the critical value. Okay, for example, let's say I have 2.06, negative 2.068 and positive 2.068 as my critical value. And let's say my test statistic's negative 2. Negative 2 is inside of these two, so therefore I can't reject. If you think of the number line. I want to see another example. Okay, let's do another one here. Do we have one? No, we don't. And, what am I gonna do? Cut into a homework problem? I can't do that. Shoot. Wait. No? I have no other example ready. Hang on.
We could just do the working class problem.
Well, what class problem? In class?
The economic class.
I can't hear you. Let's look at the homework. The first problem, I'm literally giving you the null hypothesis and the alternative hypothesis, and I'm asking you to use the p-value approach. But look at this standard deviation. Let me read this to you. A sample of 25 observations yields a sample mean of 46 and a standard deviation of 10. I did not give you the population standard deviation. It's in the same sentence described about the sample. So that's how you know this is a T, right there. But it's the p-value approach. Now let's go down to the second one. Consider the oh, I made it easy again. You don't even have to give me the hypothesis. The mean, the null hypothesis that the mean's greater than or equal to negative 12. Wow, what, that equals kind of light, isn't it? And the alternative is that the mean is less than negative 12. A sample of 28 observations yields a sample mean of negative 10 and a standard deviation of 4. There it is. That was a sample standard deviation. It was right in the sentence about the sample. Nothing about the population standard deviation, so that's how you know it's a T. This one though says, calculate the critical value. Use the critical value approach. So this is asking for the critical value approach, but it's T. These are all T's. Number 3, a machine that is programmed to package 1.2 pounds of cereal in each cereal box is being tested for its accuracy. In a sample of 36 cereal boxes, the mean and the standard deviation are calculated to be 1.3 pounds and 0.12 pounds, respectively. It literally gave you the data from the sample. It said nothing about the population standard deviation. It was all part about the sample. It gave you both the mean and the standard deviation about the sample. That's how you know this is T. And then which approach? Critical value approach on this one. Critical value approach. So you got the first one's asking for p-value approach, the second one's critical value, the third one's critical value approach. The fourth question says, use the information from problem 3, describe in words your results mean as far as rejecting or not rejecting the null hypothesis. Where's the rest of this? Like, use the information from that to describe in words what the result means as far as. Okay, here it is on your homework, where you gotta take number 1, 2, and 3, you get to the point to where you're telling me reject or not reject. But when you get to number 4, you gotta tell me what it means to reject or not reject as far as number 3. Now look what number 3 is measuring. Does the machine package the cereal boxes with 1.2 pounds or not? All right, it's asking for the accuracy. Is being tested for accuracy? Is it being tested to be more than 1.2, less than 1.2, or different than 1.2? You gotta ask yourself that. Give both hypotheses, and then your number 4, I'm almost telling you what to say. Your number 4 should be all about whether you reject it or not reject it, and what it means about that machine filling those cereal boxes with 1.2 pounds of cereal or not. That's what your sentence should be telling me. Either you're gonna be telling me that the evidence is showing that it is filling up at 1.2 pounds, or it's not filling up with 1.2 pounds. Those are the words for number 4, basically. All right, we're supposed to get into the confidence intervals. How are we doing on time? I want to start the next lecture with one more example of doing a critical value approach with a T, and then we're going to confidence intervals on the next lecture right after that. All right, so we're going to learn confidence intervals and then I'm going to really put in stone how you describe in words what it means to reject or not reject. All right, I will see you on Thursday.
So